products. With the rise of 5G, AI and HPC, processors have begun to develop in the direction of high-speed computing, small size and low power consumption. In addition to developing more diverse I/O terminal applications, how to make high-value added products has become a major focus of manufacturers' layout. Major smartphone brands have also begun to introduce AI technology into their products to improve voice and image recognition and processing performance, adding more added value to smartphones and attracting consumers to buy new models. This trend also drives baseband frequency technology growth of new application chips other than chips. In other words, both existing products such as PCs, NBs, and servers, as well as AI innovative applications, will require faster and lower power consumption processes, which will also lead to a significant increase in the demand for high-end semiconductor processes. Qualcomm, Nvidia, ARM, AMD and other major manufacturers, the latest high-end products in 2019 all use 7 nanometers process technology. On the other hand, other innovative applications of AI will also drive GPU, DSP, ASIC, FPGA and Neuron as the demand for chips grows. The above-mentioned computing units will also require advanced processes below 10 nanometers, even 7 nanometers processes. Therefore, it is expected that the demand for 7 nanometers processes will grow significantly from 2019. In 2019, several chips have been launched using the 7 nanometers process, and the application areas are mainly cloud computing, data centers, AI chips, self-driving chips, or some special applications with high unit prices. Further understanding will find that all 7 nanometers products, including Qualcomm, AMD, Broadcom, Xilinx and NVIDIA, are handed over to TSMC for foundry. It is worth mentioning that Samsung, which also belongs to the Advanced Process Leader Group, originally expected to use its own 7 nanometers process to produce the Exynos 9820 mobile processor, but it was finally stopped due to factors such as yield, and the product is currently produced using the 8 nanometers process. Advanced process capacity improvement depends on EUV optimization. The evolution of the IC process, in terms of the development in the first half of 2019, although the 7 nanometers process has a high volume, the actual production capacity is not high, accounting for only 7.8% of the production capacity of the 12-inch factory. To improve production yield, 7 nanometers needs to invest more cost. The goal of manufacturers in 2019 is to increase production capacity. Manufacturers such as TSMC also expect to increase the light source intensity of EUV systems from 280W to 300W by the end of 2019, and expect to reach the goal of 350W in 2020, so as to improve production throughput. However, with the introduction of EUV technology, the cost of advanced processes below 7 nanometers will also rise. In this regard, Lou Majan analyzed that although the number of gross dies, cut out of 7 nanometers process wafers has increased, the overall production cost has not necessarily decreased. The main reason is that other costs have also increased, including the cost of mask equipment, materials and other equipment. Compared with the previous process, its cost growth rate exceeds 30%. Therefore, according to the current actual production situation, the total cost is higher than that of 10 nanometers and other processes, and the technical challenges are also greater. This is why manufacturers choose the most stable production yield and production capacity in the current market when placing an order. OEMs